today what I wanted to do is I wanted to talk about equations and general solutions. And it's not something that we've actually had a chance to talk about before in trigonometry. We've done a lot of general trig, but we haven't spoken about general solutions or equations, that kind of thing. And we know that there's always going to be a question on this. And often it's one of the sort of more difficult sorts of questions that they expect us to be able to do. All right, so I wanted to start the class off by asking you, what do you understand a general solution to be? I mean, when you're doing trig and you're writing a test, or you're working in class with your teacher and they say to you, you need to find a general solution, what is the question asking for? What do they want from you? What are you supposed to be doing? Can anybody explain that to me in a simple way?
Let's shake the coldness out of us, guys. Let's
What's
go.
What's a general solution matrix? What are they actually asking you for?
Anything that comes into your mind, you can put on the chat, or you can actually just unmute and tell us.
Absolutely. And even if you don't say 100% the right thing, that's the whole idea. That's why we're here, to have these discussions and talk about what this stuff means. Okay, so a reference angle. So a reference angle is part of it. The general solution is not the reference angle, but we use a reference angle, sure. So it involves a reference angle, sure. What else does it involve?
I see Vio is like in his blanket. Vio, anything coming through in your mind? Anything that you want to tell us, Vio Luzi?
So yes, it involves a reference angle. What else does a general solution involve? Can you give me an example of a general solution, even if it's just one that you've made up? What would it look like?
Let's go, metric. Anything.
Shame these guys are.
They're too quiet today. I
They're
promise
very
you, the
quiet
brains are
today.
frozen. Yeah.
Okay, so in the other class, somebody said something about quadrants, which is also true, because we've got to know which quadrants we're working in. So that's part of it. So there's a little bit of something from me. You've got to know which quadrants you're in. I'm very bad in trig, says Vuyo. You know what, Vuyo? You are not alone. Most people really struggle to understand what trig is and what it is that you're trying to do, especially when it comes to something like a general solution. It all just seems like a load of garbage. Let's see. You're on the right track. Is it Ariane? Arian? I don't know if I pronounced your name correctly. I think a general solution gives the coordinates of a certain part of the graph that satisfies the solution. You're on the right track. Chloe, we're in the same submarine here, friend. Okay, all right. So what I'm going to try and do is I'm going to try and explain what a reference angle is to you, but I'm going to try and differ in a slightly different way that I did. Yes, Kimea, correct. K is an element of the integers. What does the K represent? Why is the K there? What does the K do? Why is it part of our general solution? Can anybody answer these questions? So in my mind, what's always so interesting for me as a teacher is that we teach you guys these things thinking that we've taught you to understand what it is that you're doing. Whereas in actual fact, you're just watching what we do on the board, and then you're copying us, and you're just doing it because we're telling you that you need to, and you do it because you need to get the marks to pass your exam. There's not really any sort of like deeper connection between what does this mean? Why am I doing it? How can I apply this information to other situations? And trig is a difficult one because I believe you only really begin to understand how trig works when you learn about general solutions in conjunction with the graphs, because your general solution comes from your graph. But often we don't teach the two together. Yes, you're right. There is a point of intersection. There is a point of intersection. You're quite right. So for example, Pinga, you're on the right track here. If I scooch over here, I've got, sorry, this is from earlier. I've taken a screenshot of a program, an online program that's actually free, by the way, if you want to go, if you're so inclined. It's called Desmos. I don't know if any of you have heard of it. I'll just write the name here. It's called Desmos, and it's a free online graphing calculator, and you can actually use it not just to graph trig graphs, but any function, cubic functions, parabolas, blah, 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 blah. So it's, if you've got time to go and play around with it, it's actually really, really cool. Now, the blue line, this is a trig, a sine graph. Okay, so the red line is a sine graph. It is the graph, let's choose a red color so that it is the graph y equals sine x. Okay, so the x part over here, this is your angle. So these are your values here on your x-axis, right? The y is your output. So that's these values here, not that it could ever be that much, on your y-axis. So if I say to you that sine x, let's use a different color. If I say to you that sine x equals a half, that would be like what the blue line is, because here, this is a half. Okay, there's one over there. Here's a half. So if y is equal to half, y is equal to half is a straight line. And I'm drawing this straight line all the way across my trig function, and I've gone as small as minus 700 and something and as big as 700 and something. So when I have got the graph y equals sine x, and I say that sine x is equal to a half, what I mean is that there are different solutions that I can find, all when sine x is equal to a half, okay? So in other words, I can find the solution over here. Any idea what that value would be? Anyone know what this value over here is? Think special angles. $30 degrees? Does that make sense to everybody? 30 degrees? So here are all your points of intersection, Penga in gray. Okay, 30 degrees. So this one over here is 150. Why? It's quadrant 2, 180 minus your reference angle of 30 is 150 degrees. So there's another solution, 150. Okay, so now let's go forward. All right, so over here, we've got another solution. And if we go forward over there, we've got another solution. And if we go back over here, we've got another solution. And if we go back over here, we've got another solution. So there are lots and lots and lots of places where sine x is equal to a half. Okay, so just on the screen in front of us, we can see that there are 1, 2, 3, 4, 5, 6, 7, 8 places just in this particular interval where sine x is equal to a half. That's why they give us an interval to work in between. So they tell us to solve for theta, but they say theta is an angle that is between minus 180 and 180, so that we're not here forever and ever and ever working out all the possible angles that satisfy the particular equation. Exactly, Pinga. So the graphs intersect indefinitely, which is why you were given a restriction or a window on the Cartesian plane to look at. Okay, just find solutions between here and here. Otherwise, you'd be there forever and ever. There are an infinite number of solutions because, as you know, our x-axis gets bigger and smaller infinitely, doesn't it? Okay, so that's why they give you the restriction. Okay, so we're getting a little bit closer to understanding where the graphs tie into our general solutions. So let's go back. Actually, hang on a second. Before we go back, let's say I had this general solution. Let's do, because we've got the graph here. Let's say that I have got y equals no, let's not do that. Let's go solve for x. And then here I'm making it very simple. Sine x equals a half. And now I'm telling you that angle x is an element, and let's go from minus 450 to 300. Let's do that. And let's do that using the graph that's in front of us. Okay, so it asks us to solve for x. Sine x equals a half. X is an element from minus 450 to 300. How do you know that you are supposed to be using a general solution? How do you know that when you do this? It doesn't say find the general solution. How do you know that you're supposed to be using a general solution? How do you know that you're supposed to be doing a general solution? How do you know, Matrix, that you're supposed to be using a general solution in this situation?
You can do this, guys. You can take your notes. Hopefully you have your books.
Absolutely. Pinga, the real reason for it is because they have told you to leave the Cartesian plane from between 0 and 360. If you are solving between 0 and 360, you don't need a general solution. Okay, you don't need a general solution. So you only need a general solution. Number one, when they ask you, that's actually one of the points that I had made at the beginning. Let's just go back and fill that in. So how do we know we need a general solution? Well, the first instance is they tell you to find a general solution. So they ask you for it. They ask you for one. Second situation, the angles, or should we say the restriction that's been given to you, the interval that's been given to you, the interval given is less than, 0 degrees or greater than 360 degrees. And the second situation is where they say to you, solve for x, for example, if they've given you something like, say, sine 2x equals 0,7. So in other words, the angle that they are asking you to solve for is different from the angle that is given to you in the question. Then you will need a general solution. So in this case over here, we know that we need a general solution because they are telling us to solve, where is it? between minus 450 and 300? Yes, they will be, Pinga. They will be explicit. Okay, so we know we need a general solution here because we are working smaller than 0 or bigger than 360. So we know that we need a general solution. Okay. So all of us know what to do because our teachers have shown us at school. They said to us, you need to find a reference angle or a PAA. My school, they call them PAAs, positive acute angle, but if you want to call it a reference angle, it doesn't matter. What does your reference angle represent? So we all go PAA or RA, and we go shift sign on our calculator, and we put in the half, and it gives us 30 degrees. What does that number represent? What is that? What is the PAA or the reference angle? Why do we have one? What's its purpose? Why is it there? Why have we found this reference angle? It does, Pinga, it does, because it gives us a place to start. There. Okay, so where I have drawn that purple circle, that is where x is equal to 30. So this is 30 degrees over here, and y is equal to a half. That is our starting point. Okay, in quadrant number 1. Okay, because if we look at the sign of our reference, of our ratio, we can see that it's positive. So now we have to say to ourselves, okay, going back to the cast diagram, there are 2 places between 0 and 360 where sine x is positive. Quadrant number 1 and quadrant number 2. So if our PAA is 30, that satisfies where we are starting in quadrant number 1. That's the purple dot that I have drawn over here. But in order to find out what angle in the second quadrant also has a ratio of a half, I have to use my reduction formula for the second quadrant. And that's where 150 comes from. So this I'm going to do in blue. That's this bit over here. Okay. However, they want us to find solutions between minus 450 and 300. So a sine graph repeats itself every 360 degrees. So if I want to go one multiple of 360 degrees forwards, I would get that solution over there as well. Can everybody see that? The purple one, when my PAA is 30. But I can also go in the other direction. So in other words, if I go 360 degrees backwards from this point, I would end up over there. And if I wanted to, I could go another 360 degrees backwards, and I would end up over there as well, wouldn't I? Now let's consider the other place where sine x is equal to a half, which is at 150. Okay, so the light blue ones. Okay, so as far as the light blue ones are concerned, I've started over here. This is my starting point. And again, I can go 360 degrees forwards. And I could go another 360 degrees forwards, except I've cut that off. Or I could go 360 degrees backwards, one multiple of 360 degrees backwards, and another multiple of 360 degrees backwards. And that would give me that solution over there. Okay. So now we would find our general solution. Okay, so we would come along after we've calculated what our PAA is. We would then write X, our angle, is equal to, in the first quadrant, so this is quadrant number 1, our PAA of 30 plus K times, let me just move my mouse out the way, K times 360. K is an element of the integers. So this refers to the purple dots. If K is equal to 0, then that is this solution over here where my pen is now, this one at 30. But if I make K equal to 1, 1 times 360 is 360, plus 30 is 390. That's this solution over here at 390. If I make K equal to 2, then I can find another solution somewhere on my curve that's going to be bigger, up here off onto the right-hand side that's been cut off. Does that make sense to everyone? How are you feeling, Matrix? Is this making sense to you? Yes? Okay, let's do the other one in light blue. Okay. Or X would be equal to, it would be 180 minus our PAA because that's our second quadrant. And that's where the 150 plus K times 360, K is an element of the integers, would come from. So now you are looking at the light blue dots. Okay, look at the diagram and look at the light blue dots. When K is equal to 0, guys, that's this answer over here, 150. All right. If I make K equal to 1, 1 times 360 is 360. And if I add 150 to that, I'm going to end up with an answer of 510, which is exactly what this is. Ah, man, don't move the dot. There, that's 510 degrees. Right. If I now want answers that are negative angles, right, then I've got to go back the other way. Right, so again, let's go back to the purple one where K was equal to 30. If I make K equal to -1, then I'd get 360 times -1, which would give me -360. And then to that, I need to add 30 degrees. That's minus 330. Look here, guys. Here's minus 330 there. That was if K was equal to -1. If K is equal to -2, then I'm going to say 360 times -2 is minus 720 plus 30. That gives me minus 690. That is this one over here. Okay, so I'm using my general solution to find values that solve my equation up and down along my curve. Okay, I can do the same thing with the blue one. Okay, we've looked at what happens when we made K equal to 0 or K equal to 1. What happens when we make K equal to -1? Then we would have 360 times -1 plus 150 minus 210. That would be this, minus 210. If I made k equal to minus 2, I'd have 360 times negative 2 plus 150. That would give me minus 570. That's this answer over there, minus 570. So you can see there are two general solutions that are giving you answers on this curve, either where your angles are negative or where your angles are positive. But we only wanted between minus 450 and 300, didn't we? So anything that's smaller than minus 150 is too small, and anything that's bigger than 300 is too big. So this x is an element of minus 450 to 300. It's giving you a barrier. There's the lower bottom, the lower end. Can't be smaller than here. And here can't be bigger than there. Can't be bigger than this. So what angles between the two pink lines are our solutions? Okay, so it would either be where theta was equal to minus 330, or where theta was equal to negative 210, or where theta was equal to 30, or where theta was equal to 150. Those would be our appropriate solutions. Okay, the minus 330 and the 30 come from the first general solution. This one over here. Okay, the minus 210 and the 150 come from the second general solution. That's that one over there. Okay, questions? Are there any questions? Ping, are you happy? Okay, so Ping is happy. How does everybody else feel? Keithlin's happy. Lesejo. No, Sibongile. Not at all, not at all. I am using the graph to explain the concept behind it to you. All right, that's why I'm doing it this way, so that you understand. When they say to you, find a general solution, you understand what you are doing. Okay, so this is how your teachers should be teaching it to you at school, and then you can go ahead and go and look at the questions. But you need to understand what it is that you are doing, and that's what I'm trying to do today. Okay, any questions? That's exactly what I want, Voyo. You've never thought of it this way because perhaps no one has ever explained it to you like this. But how do you understand what a general solution is if it's not explained to you like this? You have to see the connection between the general solutions and the graphs. Okay. Because then you can start accessing the higher order questions and truly start applying what you know. Okay, so this is what I want for you, Voyo. Okay, so we've spent half an hour explaining what a general solution is, where the K comes from. Cool, I'm glad, Sibongile, that's great. That makes me very happy when you feel like that. Okay, so let's go and have a look at all the different types of questions that they could possibly give us. Okay, so they can have compound angles, they can have double angles, they can expect you to factorize. There's all sorts of weird and wonderful things that they could potentially give us. I mean, I could spend 5 lessons on general solutions with you and still never show you everything that could potentially be asked. That's one of the drawbacks of CAPS. But anyway, let's practice as much as we can. So the first one is not meant to be particularly difficult. This one has got a compound angle in it. All right. So the clue here is that when you see cos theta cos 24, sine theta sine 24 equals 0,715. Again, how do you know that you need to do a general solution? Because they are asking you to work smaller than 0, in this case, smaller than 0, not bigger than 360. You need a general solution, but you've also got to use compound angles. If I give you the starting part, let's see if you guys can do the rest on your own, okay? So we recognize on the left-hand side of the equation that that is a compound angle, yes? So using our compound angle formulae, we could then do the reversal of the expansion on the left-hand side. That would give us the cos of theta minus 24, that's our angle, is equal to, there you go. All right. So I've done the reversal of the expansion. I'm going to leave you guys to do the rest of this. Okay, so you're going to find your PAA or your reference angle, and then you're going to use that to solve between -90 and 90. Or actually, hang on a second. Am I expecting you to do too much? Do you want me to do this as an example with you rather, or do you want to try it on your own?
Maybe an example. Yeah, that's what
Oh,
we
you want me to do it
typically
as an
look at.
example? Okay. All right. Sorry,
Yeah.
guys. Sorry. Okay, so now on our calculators, we are going to go. We're going to find our PAA or our RO. We're going to go shift cos. And we're going to put in that value of 0.715. And we get an RA or PAA of 44,36, rounded correctly to 2 decimal places. Okay. Your ratio is positive. So there are 2 places where cos theta is positive. All right, 2 quadrants. Quadrant 1 and quadrant 4. In quadrant 1, your angle theta minus 24 is equal to your PAA plus multiples of 360, because your graph repeats itself every 360 degrees. So that's quadrant number 1. Let's collect this together. So this would give us 68,36 plus k times 360. K is an element of the integers. That's quadrant 1. That's our first general solution. Or, okay, the other place where cos theta is positive is quadrant 4. So our angle is theta minus 24 is equal to our reduction formula for the fourth quadrant is 360 minus our PAA of 44,36 plus k times 360. K is an element of the integers. And again, we would need to collect our like terms. And we end up with 339,64. Okay. Now, if they had said to us, just do the general solution, we would stop there. There's our general solutions. But they didn't. They told us to solve between -90 and 90. Okay, so they are giving us an interval. Oh, sure. Nonela, you're going to go shift cos, and then you're going to put in your ratio 0,715. So when you go shift cos, you are telling your calculator to find an angle. Okay, so it will give you the acute angle associated with that ratio. Sibongile, you're welcome to unmute and speak, Sibongile.
Bongile, you can unmute on your side if you have a question, because I see that your mic is working, everything is working, so you should be able to talk to us.
Yeah, so Sibongile, when you say, ma'am, would it be wrong if there is one answer? What do you mean? Do you mean one general solution?
Yes, ma'am.
Okay, so Sibongile, when it comes to a tan graph, okay, it is possible for you to only work with one general solution. You don't need both if you work with k times 180, because the graph repeats itself every 180 degrees. But when it comes to a sine graph and a cos graph, you need to have two general solutions. Okay, because the graphs repeat themselves every 360. Does that answer your question? Okay.
Yes, ma'am.
Okay.
So, ma'am, I'm using my mom's phone because my phone is flat.
That's fine. No problem at all.
It's Anaka speaking.
Oh, Zanaka. Okay. No, that's no problem at all. Does that make sense to you, Zanaka?
Yes, ma'am.
Okay. All right. So it's only with a tan graph that you can use one general solution. As I say, if you go k times 180, all right, because the tan graph repeats itself every 180 degrees, if you make k equal to 1 or k equal to 2 or k equal to 3, you'd pick up all those other solutions anyway because you're working in multiples of 180. Whereas that, unfortunately, that doesn't happen with a sine graph or a cos graph. So I hope that answers your question.
Thank, ma'am.
No problem. All right, so now guys, in order to go and answer the question and solve these angles, we've now got to take things one step further and use these integer values of k. So remember, if k is an integer, k could be 0, or k could be equal to -1, or k could be equal to 1 or -2 or 2 or whatever the case might be. But remember, we want answers between -90 and 90. So if we're having a look at this general solution over here, and we made k equal to -1, we'd have 360 times -1 plus 68.36. This gives us an answer of minus 291,64. So if k equals -1, we get a value for theta, which is minus 291,64. But that's too small because it's much, much smaller than -90. So that is not going to be a solution in this case. So now we're not going to consider answers or k values that are smaller than -1 because they're all going to give us angles that are smaller than this, which we know is smaller than our lower bound. If k is equal to 360, we'd say 360 times 0 plus 68.36. That gives us an answer of 68,36, which is great because that lies between these two. If k was equal to 1, we'd say 360 times 1 plus our 68.36. And again, we'd get an angle that was too big. So here it would give us an angle of 428,36 degrees, which is much bigger than 90. So that is not a solution in this case either. So we have exhausted all possible solutions using this general solution. Now we need to go to the other one. Okay, and same story. Okay, we need to work with integer values of k. All right. So if I start in the middle of the number line, and I say that k is equal to 0, it would be 360 times 0 equal plus 339. That means that theta would be equal to 339,64. That's too big because it's bigger than 90. So that is not going to be a solution. So I'm not going to consider k equals 1 or k equals 2 or k equals 3 because they're all going to be bigger than my upper bound. So now I want numbers that are smaller, integer values that are smaller than 0. So let's try -1 first of all. So 360 times -1 plus 339.64. And that gives me an angle of -20,36. Perfect. It's between these two. But if I want to be 100% certain, let me consider what happens if k was equal to -2. So I'd say 360 times -2. Now I need to add 339.64. That gives me an angle of -380,36. Too small. So now I've exhausted all my options with the second general solution. So there are only two values of theta that satisfy this equation that are between -90 and 90. Okay, and that is either where theta is equal to -20,36, or where theta is equal to 68,36. Okay. Any questions? You can, Pinga, if you want to list your answers, you can do that as well. If you do that, Pinga, you've got to be careful of the way in which you do it. So if you say theta is an element of, and you use curly brackets, you've got to put the smaller, you've got to put them in order, and you've got to put this, it's got to go from smallest to biggest. So you can do this. Oh, sorry, that's supposed to be a comma. And then you can separate them by semicolons. And then here would be 68,3. Ugh, man, stupid mouse. Don't know why it doesn't want to give me my bracket there. Okay. So you can do that too if you want to, Pinga. Okay. Keithlin, you happy? Okay, so what I'm hoping to have achieved this lesson is to explain to you what a general solution is and what it is that you are trying to do. Okay, and I'm hoping that you will then, when you are asked to do general solutions in the future, that you will understand how it is linked to the graph, what the restriction means, whoopsie daisy, what the value of k means and what it allows you to do. Okay. The rest of us, are we happy? Thumbs up, thumbs down. Okay, Lesejo, Trish. Sharik. Ntlafatsung. Molebo. Okay. Pinga. Blessing. All right. Lesedi, if they tell you to find angles in a given interval, then yes. If it just says to you determine the general solution, then you would stop there where the orange ends and you wouldn't do the other bit. But if they give you an interval and they ask you to solve in the interval, then you would need to do the purple and the black bit as well. If they just want a general solution, you would stop with the orange. Okay, does that make sense? Okay, so Vuyo, that answers the same question. Okay, if it just says determine the general solution, you would stop at the orange. Okay, the purple and the black is only if they told you to solve for theta and they gave you an interval. Okay, so like if you have a look at this one, in number 1 here, determine the general solution. Here, they don't want values for theta that solve the equation. They just want the general solution. Pleasure. Okay, so shall we try, before the end of the lesson, shall we try this one here? This number 1a. Maybe what I should do is just get that. Just going to need that again. And let's put it over there. Okay, let's try 1a and let's see how that goes. We've got just over 10 minutes. Okay, so we're just doing the general solution, guys, because that's what it asked us for.
Let's give it a try, guys. Let's give it a try. And it say when we are done on the charts like this, we can see you are done.
Yeah, absolutely. No, I'm connected. So again, put done in the chat when you finished. Cool, Pinga, send me your, okay, so Pinga, Sibongile, just DM me your answers if you can. I know it's a little bit of a tough one to type. Pinga, Sibongile, I'm not sure if you're interested in trying any of these ones here. We haven't spoken about those yet. That's it. Bali, good job. Okay, Pinga, I got a different answer to you. Okay, Lesedi. Okay, so I'm going to do it on the board. Okay, so in other words, you just send me a direct message. Okay, Lesedi. So if you click on my name and then where it says Lee or whatever, then you just direct message me. Yes. Ekonoruka. I hope I said that correctly. Correct. Good. Well done. Okay, so since there are only 6 minutes left, what have I done with my pen now? There it is. I'm going to go through the answer just in case there are. Blessing, that's not the answer I got, but no stress. We're going to go through it together. I think this is definitely something that we need to spend more time on. Okay. All right. So we would again have used a compound angle, all right, in order to be able to solve this particular problem. All right, we see cos, sine, sine, so we know that it is a cosine compound angle, and doing the reversal of the expansion, we would have ended up with the cos of, and we've got to write very carefully here, it's 4 theta minus 40 degrees is equal to -1. Okay. Now, when we find our PAA, all right, and we put in our 1, we end up with a PAA of 0 degrees. That's it. Well done. Msomi, yes. Sharik, yes. Good job. Okay, in this case, Vuyo, what you were asking me earlier, there's only going to be one solution here because both general solutions are the same. Okay, now we're going back to the cast diagram, aren't we? And we are saying to ourselves, our ratio is negative. It's -1. In which 2 quadrants is cos theta negative? In quadrant 2 and 3. So in quadrant 2, our reduction formula is 180 minus. In quadrant 3, it's 180 plus, right? Now, if we have 180 and we subtract 0 degrees, we're still going to get 180, aren't we? And if we're in quadrant 3 and we say 180 plus 0 degrees, we're still going to get 180. So because our PAA is 0 and we're working in quadrants 2 and 3, it means our two different general solutions for quadrant 1 and quadrant 2 are going to end up being the same. All right, so we come along and we say our angle is 4 theta minus 40 is equal to 180. This is now quadrant 2 minus 0 degrees plus k times 360. K is an element of the integers. Okay. So now when we move, let's just get that out the way. Oh, yes, man. Just move. Give me a hard time. Okay. So now 4 theta is left on the left-hand side. We're transposing the negative 40. That gives us 220 plus k times 360. K is an element of the integers. And now, matrix, we have to divide every term in the equation by 4. So that gives us theta equals 55 degrees plus k times, this also has to be divided by 4. So this is 90. And we end up with that. Okay, so this was quadrant 2. In this particular case, quadrant 3 gives us the exact same answer because whether we add 0 to 180 or subtract 0 from 180, it's not going to change this 180. All right, so we do not need to do the second general solution to get the same answer.